Hello friends, welcome to Bhavesh Sirki online class. Hello friends, today we are going to see topic of indices. Exercise 7a we are going to see. Before starting with this exercise, I would suggest that you should know all the 7 rules and something I am writing down on the board. Square root of 5. This I have written in words. If I want to represent this in the form of symbols, then I can write it down as this is square root of 5. This is also written down as 5 raised to 1 upon 2. Say for example, I have cube root of 5, then symbolically it will be written down as 3 inside this V sign. 3 is not outside that V sign. Cube root of 5 is written down as V sign. Inside V sign there is a root sign. Inside V part of the root sign 3, and inside the root sign there is 5. And in the index form it can be written down as 5 raised to 1 upon 3. If somebody is asking me nth root of a number, say nth root of A, it will be written down as A will go under square root sign and n will be inside the V sign, and the same thing can be written down in the form of an index as A raised to 1 upon n. Along with this, let us remember one more rule, because I have seen kids making many mistakes over here. A raised to negative m can be written down as 1 upon A raised to m. Same rule in the form of a fraction. Suppose I am having p upon q whole raised to negative r, then q upon p whole raised to positive r. The same rule here with a single number and on right hand side in the form of a fraction. We shall see an interesting question. Question 1 sub question 2. It states that simplify or evaluate 5 raised to negative 4 multiplied by 125 raised to 5 upon 3 divided by 25 raised to negative 1 upon 2. So first of all, I will try to make all the bases same over here. Here base is 5, here is 125, here is 25. I'll try to make the smallest possible base over here for all the 3 numbers. I am writing down for first number as it is, 5 raised to negative 4. 125 is nothing else but 5 raised to 3 whole raised to 5 upon 3 divided by 25 is nothing else but 5 squared whole raised to negative 1 upon 2. Now we shall apply a very simple rule. 5 raised to 3 into 5 upon 3 divided by 5 raised to 2 into raised to negative 1 upon 2. This becomes 5 raised to negative 4 multiplied by 3, in the denominator and numerator gets cancelled. 5 raised to 5 divided by 5 raised to negative 1. And we know the rules that if bases are same and we have a multiplication over here, so what can we do is 5 raised to negative 4 plus 5. These two indices will be added, and it is in the form of a division. Whenever it is in a form of a division, we have to do subtraction minus of minus 1. So what we will get over here is, so 5 plus 1 6, 6 minus 4 is 2, so this becomes 5 squared. Final answer is 25. Key point to remember, make all the bases same. We shall take one more question. Question 1 sub question 3. It reads like 27 upon 125 whole raised to 2 upon 3 multiplied by 9 upon 25 whole raised to negative 3 upon 2. Now if you look at 27 and 9, they are the part of they are multiples of 3. 125 and 25 are multiples of 5. So what I am going to do, I am going to make the base as 3 for this. So it will be 3 cubed over 5 cubed. 125 is a cube of 5 whole raised to 2 upon 3 multiplied by 3 squared. 9 can be written down as 3 squared. This is 5 squared raised to negative 3 upon 2. Now both are having same power, so I can write down 3 over 5 whole raised to 3 into 2 upon 3 multiplied by 3 upon 5 whole raised to 2 multiplied by negative 3 upon 2. What happens here is 3 upon 5 whole raised to 2 multiplied by 3 upon 5 whole raised to negative 3. And my dear friends, what you can see here is both of them are having same base. So what we can do is we can apply the first rule of the indices, 2 minus 3. This will fetch us 3 upon 5 whole raised to negative 1. And dear friends, most of the time we do not write the final answer with negative index. So we have to convert this negative index into positive index. So we shall write it down as 5 upon 3. This can be the final answer. Answer can be represented in this form. Few of the schools are insisting answer in decimal. Few of them are insisting in mixed fraction. So you will take the call as per your school whether to go for decimal answer or a mixed fraction answer. But the calculation part gets over here. It depends on your school what type of answer they are expecting. We are going to see a very special question, question 2, sub question 2. It states that a plus b whole raised to negative 1. This dot means multiplication. A raised to 1 plus b raised to negative 1. I'm sorry, a raised to negative 1 plus b raised to negative 1. Now we understand this very well, my dear friends. This negative 1 is power of entire a plus b. So if I want to convert that as a positive power, I will write down a upon b whole raised to 1. Whereas in the second bracket, a raised to negative 1 is an individual power. So this will be written down as 1 upon a plus this will be written down as 1 upon b. Raised to 1 for any number, the number remains unchanged. And here you need to know the bases, the denominators are not same. Denominators are not same. So I'm trying to multiply here by b to make same denominators. Here I'm multiplying by a. This is equalizing the denominator. Some of them know it very well. If you are not knowing it, please check your basic concepts of fractions. So 1 upon a plus b remains as it is. Now as you know, in the case of addition, if 5 plus 3, if I write down, it is equal to 3 plus 5. What I mean to say is here a b plus a or a plus b means the same thing. So here I am writing a plus b in the numerator. In the denominator, we have a common denominator now, AB or BA. That means I can just write down AB. If you look at the first denominator and second numerator, they are same. So I can cancel A plus B. So I am left out with 1 over AB. This is the final answer. Key point to remember in this question, here the index was for the entire bracket. So entire bracket has gone down. In this bracket, individual numbers had a negative power, so only each power has gone down. And second point to remember is taking LCM of both the denominators, then only you can do addition or subtraction. Question 2, sub question 3, my dear friends, it's a little different. Till now we have applied the law of indices, first law of indices as a raised to m multiplied by a raised to n is equal to a raised to m plus n. We have used this particular formula from left to right. In this we are going to use it from right to left. What I mean to say that if I am having 5 raised to x plus y, then I can write it down as 5 raised to x multiplied by 5 raised to y. The same formula, I am using it in a different way. Let us understand how I am going to apply and why that is needed here. Here 5 raised to n plus 3, so I am making it 5 raised to n multiplied by 5 raised to 3. I hope you understand. I have applied this particular concept here. Minus 6 into this 5 raised to n into 5 raised to 1. Again I have applied the same concept. In the denominator, what can I see is 5 raised to n, I can take it out common. This factorization topic will be helpful to you over here. So 5 raised to n I am taking out common. So if I take out common over here as 5 raised to n, first term will be left out as 9, second term will be left out as 2 squared. Now if I look in the numerator part, you look at the numerator part. Again in the numerator, first term contains 5 raised to n as well as the second term also contains 5 raised to n. So 5 raised to n I am taking out common in the numerator. What will be left out is 5 cubed minus 6 into 5. I hope this part is pretty clear to you. Here 5 raised to n, 5 raised to n has taken out common. Now this becomes 5 raised to n multiplied by 9 minus 4. Here you can see. Now in the numerator you have 5 raised to n, denominator you have 5 raised to n. This two gets cancelled. This becomes 125 minus 30 over 9 minus 5 will be 4. 9 minus 4 will be 5. And my dear friends, I have seen students doing such a big mistake. Either they cancel this or sometimes they cancel 5 and 125. Sometimes they do that way. Here they do cancellation like this. If you are doing any of this, it is absolutely wrong. What you have to write down is correct way of writing down this particular answer is first I'll rewrite that particular statement 125 minus 30 over 5. The subtraction value is 95 in the numerator divided by 5. Answer is 90. Key point to remember, we are going to apply the first rule in a reverse way. Here we did, and then taking out 5 raised to n or whatever number can be taken out as common. You have to be carefully take out those numbers as a common number. Let us see, this is represented in a different way. It's not a different question, represented in a different way. At the start of the lecture, I mentioned that this number can be written down as 1 upon 4 whole raised to half. Remember, this 0.01 is nothing else but 1 upon 100 whole raised to negative half. And 27 I can write it down as 3 cubed whole raised to 2 upon 3. Now, this is nothing else but 1 upon 4 is nothing else but 1 upon 2 square whole raised to half. This is nothing else but 1 upon 10 squared whole raised to negative 1 upon 2. And here 3 cubed multiplied by 2 upon 3. So if I look at this particular thing, first fraction, half raised to 2 multiplied by half, that is 1 upon 2. This is something interesting. If this power comes in the top part, it will become negative power. I hope you remember one of the rules we discussed at the start of the lecture. And lastly here, this denominator 3 and 3 gets cancelled, so I get here 3 squared. Now what happens here is I made an error here, my dear friends. I am changing it. Here it is subtraction sign. Okay. No difference in whatever steps we have calculated, only it will be effective in the last part. And here also I made an error. Instead of multiplication, I wrote multiplication instead of addition. Negative into negative becomes positive, so this becomes 10 minus 3 square, that is 9. Half plus 10 minus 9 is 1. This is 1 and half. And as I told you, whatever way your school is expecting answer in the form of a mixed fraction, improper fraction or decimal, you'll write down, you'll confirm with your school teachers and you'll write answer in the same form. As I told you, it's not a different question, represented in a different form. And if you remember this part, I explained at the start of the video lecture of this particular session. Question 4, sub question 1, not a difficult one. 3 raised to negative 4 upon 2 raised to negative 8 whole raised to 1 upon 4. Now what I am doing is I am just converting this negative power into positive, this negative power also into positive. So this becomes 2 raised to 8 over 3 raised to 4 whole raised to 1 upon 4. And if you remember the rule, this 1 upon 4 will be applicable to the numerator as well as denominator. So what I get over here is 2 raised to half multiplied by 1 upon 4, 3 raised to 4 into 1 upon 4. 4 ones are, 4 twos are, this becomes 2 squared, and here 4 and 4 gets cancelled, 3. So again, answer can be written down mixed fraction, decimal, or whatever way your school tells you. The key point was negative 4 becomes positive 4. You have to change the numerator to denominator. That was discussed at the start of the lecture. And my dear friends, we are coming to super special question. Let me tell you, it really means super special when I say you can give as many stars as you want. I am giving it as a 5-star question. And let me tell you why I call it as 5-star question, because many a times you forget the rules of opening up the brackets. So the smallest bracket is a line bracket, which you have studied in grade 6. Then bigger bracket than line bracket is a round bracket. Bigger bracket than that is curl bracket, and the biggest bracket is a square bracket. Now we have to follow the rules that first of all, smallest bracket, that is line bracket, will be open. But here, my dear friends, there is no line bracket, so I have to go to the next level. Next level is round bracket. You can see this is a round bracket, so I have to see it as a round bracket. And before I start solving this particular question, let me tell you, I have seen quite a few students making error in copying this question. And mind it very well, you have to copy it very carefully, and if you make a smallest of the error in copying the question, definitely your steps will be wrong. You have to be very careful. Where is square bracket, where is curl bracket, where is round bracket, where the negative power comes into play, etc, etc, etc. That is one thing I have seen. And second thing, kids are making mistake while doing the calculation of the question. A few minutes back we saw that 1 upon a plus 1 upon b, some kind of that question. We had equalized the denominator. So here you need to equalize the denominator at few cases. And let me tell you, this is not a difficult question, but here is the test of your patience. Those students who have a lot of patience definitely will able to do this question at the first go. And as I told you, patience as well as your concentration also will be tested. And if you're not concentrating or not focusing, and if you are not having patience, you will make a mistake. So first of all, as I told you, that I will be going with the round bracket first. So my square bracket remains as it is. Observe this carefully. So 1 minus curl bracket, 1 minus. So I have to change this particular part. And just now we had seen that if any number has the raised to negative power, we have to take its multiplicative inverse. And my dear friends, here you will not write round bracket, because we have already operated the round bracket. Now coming to the second part, as I told you, you need to know the denominators making equal. Here it is 1. If I remove this was 1 minus, or 1 over 1 minus n. So here nothing is there. Nothing means 1 is there. So I have to equalize the denominator. So what will happen over here is square bracket open, 1 minus 1 into 1 minus n whole divided by 1 into 1 minus n minus 1 over 1 minus n, curl bracket over raised to negative 1, square bracket over raised to negative 1. Now as I told you, you have to be very careful in calculations. Square bracket opens 1, curl bracket opens, 1 into 1 is 1, 1 into negative n is negative n, minus 1 over, both the denominators are same, that is 1 minus n. So I am writing it down as 1 minus n, and whole raised to negative 1, square bracket gets over 1 raised to negative, whole raised to negative 1. My dear friends, you have to be, as I told you, you require a lot of patience, you require a lot of focus over here, concentration, patience, everything will be tested. 1 minus n minus 1. So 1 minus 1 becomes 0. So what is left out over here is negative n over 1 minus n whole raised to negative 1. And square bracket gets over this raised to negative 1. Now, if you remember, I told you we have to operate first round bracket. Round bracket has been operated. Now the bigger bracket than round bracket is curl bracket. So I have to talk about curl bracket whole raised to negative 1. So what will happen to this is square bracket 1 minus of minus will be plus. So this will be 1 plus 1 minus n over n. This is very important step I am talking about. Why this has suddenly become plus? Many kids ask me. Negative into negative is positive. Sir, then why you have reversed the ratio? Like, numerator upper le liya, denominator niche le liya. Now, let me tell you, here the power was -1, and we have discussed that particular rule that x upon y whole raised to -m. Then we write it down as y upon x whole raised to positive m. Coming to the fraction part again, here in the denominator of first 1 upon 1, right? I want to equalize the denominator, so it will be 1 multiplied by n over 1 multiplied by n plus 1 minus n over n whole raised to -1. This is n plus 1 minus n whole upon n. 1 into n is n. This is 1 minus n came from here, whole divided by n, because both were having n as a common denominator, whole raised to -1. Now what happens here is something very interesting. N minus n becomes 0. This becomes 1 upon n. So we are having 1 upon n whole raised to -1. And again, I am taking the inverse of that particular thing. I am applying the rule. So this becomes n. My dear friends, as I told you, it's a really super special question, and you can give stars as many as you want. I have explained it thoroughly, step by step. Please watch the video again 2-3 times and then try to solve this question. Otherwise, you may get it little deviated from the things. Hello friends, we are going to see question 7 sub question 2. If you all have seen question 2 sub question 3 properly, let me tell you, this will not be a new thing to you. You need to remember that particular rule that p raised to m plus n can be written down as p raised to m multiplied by p raised to n. This particular rule is the reverse rule of the first rule. You should remember that. Let us go into this particular question. 3 into 27, I can write it down as 3 cubed, and it has a power of n plus 1 plus 3 squared multiplied by, this 9 is 3 squared, and here 3 raised to 3n multiplied by 3 raised to -1. How does this come? I have applied this particular rule. In the denominator, I have 8 multiplied by 3 raised to 3n minus 5 into this 27, which I can write it down as 3 cubed whole raised to n. Further going into this particular question, when I look at the numerator, 3 raised to 3 whole raised to n plus 1. So this power 3 will be multiplied to each term of n plus 1. So it will be 3 raised to 3n plus 3. This is very important. Minus 3 squared, plus 3 squared and minus 1, that is 3 raised to 2 minus 1 multiplied by 3 raised to 3n. Whole divided by 8 into 3 raised to 3n minus 5 into 3 raised to 3n. Now this particular term can be written down in a little different way. You can see over here, it can be written down as 3 multiplied by 3 raised to 3n multiplied by 3 cube. We have used that particular concept multiple of times, so you should understand that. 2 minus 1, so 3 raised to 1 multiplied by 3 raised to 3n. In the denominator, if you observe this carefully, 3 raised to 3n, 3 raised to 3n, I can take it out as common. So 3 raised to 3n into bracket 8 minus 5. By that time, what happens in the numerator, that we shall check here. This becomes 3 raised to 3n common. And in the bracket, 3 cubed into 3, that is 81 plus 3 whole divided by 3 raised to 3n multiplied by 8 minus 5 is 3. These two terms gets cancelled. You get 84 over 3, which is equal to 28. Key point 1, to convert this 27 and this 27 as 3 raised to 3, as well as you need to know how this split up takes place, how 3n plus 3 has been split up as 3 raised to 3n, into 3 raised to 3. Same split up took place over here. 3 raised to 3n minus 1 is 3 raised to 3n into 3 raised to negative 1. Exercise 7a, question number 8, 9, 10. All three requires basic knowledge of identities, which we have done. So I hope you all know those identities. If you have forgotten, so before starting question 8, just revise those identities. Another thing what you need to know is, suppose I am having x raised to p all divided by x raised to negative q. It will be x raised to p minus of minus q, because division rule we are subtracting. This will become x raised to p plus q. Having said this, how this will be useful to us, that let us see over here. It becomes a raised to m minus of minus n whole raised to m minus n. So this particular concept is applied over here. And now I will just finish the first part of the question. There are three parts. First part I am going to explain you first, and then we shall go further. This is a raised to m plus n whole raised to m minus n. Now you know these two indices will be multiplied. And what is the product of m plus n into m minus n? I hope everybody knows that. And it will be nothing else but a raised to m square minus n square. My dear friends, if you simplify this particular term, then you will get a raised to n square minus l square. And if you simplify this particular thing, you will get l square minus m square. Now in this case, all the three bases are same. So I will write down a once, and all the indices will be added: m square minus n square plus n square minus l square plus l square minus m square. And if you are proper observant, m square minus m square 0, negative n square plus n square 0, negative l square plus l square 0. This becomes a raised to 0, which is equal to 1. And if you look at RHS, RHS is also 1. So we needed to prove LHS equal to RHS. My dear friends, question number 9 and 10 are almost based on the same concept. I would suggest to go through the solution, and if you are not able to understand, you can ask me, but they are based on question number 8, 9, 10 are based on identities.